Today we're going to talk about finding an exponential equation given 2 points in a modeling problem. So let's say Scott Farkas is driving along a straight level highway at 50 miles per hour when his car suddenly runs out of gas. As he slows down, his speed decreases exponentially with the number of seconds since he ran out of gas, dropping to 30 miles per hour after 20 seconds. Write the particular exponential equation expressing speed in terms of time. So you notice that they're saying express speed in terms of time. So time is our independent variable. This is our x. And the speed is what we want to find, and that will be our y value or our dependent variable. So now we have to identify 2 points here, and we certainly do have a point because we notice that we're going 50 miles per hour when time starts. So that at time equals 0, which is our x, we will be going 50 miles per hour. So that's our first set of points. And then, of course, as the car slows down, it eventually drops to 30 miles per hour after 20 seconds. So our x is seconds, 20, and 30 miles per hour, our speed is our y, and now we have 2 sets of points. So let's see if we can find the equation. We've learned that the general equation for an exponential function equals ab to the x. We know that when x is 0, the 50 is the y-intercept, and we know a is the y-intercept, so it immediately should tell us that a is 50. But if that confuses you, substitute 50 for y and 0 for x from our first point, and you get 50 equals a, and sure enough, that's our y-intercept is a. Now our second set of points, we have 30 is our y, and our a is 50, so I shouldn't put a there, but we'll put 50 times b to the x power, and x is 20 in this problem. So we have 30 equals 50 times b to the 20th. We divide both sides by 50. And we get b to the 20th is equal to 3/5. And now we need to find the value of b. So that would be the 20th root of b. So we'll do the 20th root of b is equal to the 20th root of 3/5. That gives us b on the right side. And that b is going to be equal to the 20th root of 3/5, which turns out to be 0.9747, rounded off to 4 places. So that's our b value. So our equation is y equals a, which is 50, times b, which is 0.9747, raised to the x power, and that is our exponential function. All right, our next question now is, what does your equation predict Scott's speed to be after 45 seconds? Well, we have our function, y equals 50 times 0.9747 to the x. If we want to know Scott's speed after 45 seconds, we simply substitute 45 for x. So we get 50 times 0.9747 to the 45th power. And now all we have to do is evaluate 0.9747 to the 45th power. And we get 0.3168 to round it to 4 decimal places times 50. And 50 times 0.316 is 15.84 miles per hour if we round that off to 2 decimal places. And there's our answer. So once again, just to review this kind of problem, let's go back to the beginning. You're given a modeling problem. You need to find 2 sets of points if this is an exponential function. In our case, we found 50 and 0. since at time 0, the car was going 50 miles per hour, and then at 20 seconds, the car was going 30 miles per hour. So that was our second set of points. We do our normal way of finding the exponential function given 2 sets of points. And once we do that, we can simply substitute x for a value for x, in this case 45 seconds, and we could get the y value, which is Scott's speed at that amount of time. And now it's your turn. During the 1980s, the population of a certain city was 100,000 in 1980 and 138,000 in 1984. Find the particular exponential equation expressing the population in terms of the year. If you're having trouble with this, just rewind the screencast, follow along carefully, look at the various steps, and that should be able to help you solve this problem. Good luck, and see you again next time.